topic about ECG. ECG is electrocardiography. So to understand the ECG, first we will understand the electrical activity inside the myocardium. So consider these two myocardial cell. Okay. Now when there is no electrical activity, both of the cell are at state known as resting membrane potential. So at resting membrane potential, there is minus 90 millivolt in case of myocardium. So in that case, there are more negative ions inside the myocardium and more positive ion outside the myocardium. Okay, let's suppose action potential reached here. So action potential reached, so some positive ion entered inside. So after some positive ion enter, this is like resting membrane potential. After some positive ion entered, action potential will reach like this value. After reaching this value, this is known as threshold potential. So after reaching threshold potential, the sodium channel present myocardium will open. So when sodium channel will open, sodium ion which are present outside the cell will start entering inside the cell. So it will cause a depolarization, a surge in depolarization occur, and it will reach point 1. Okay? So after reaching the point 1, some other channel will also open. These are known as potassium channel, and potassium will start moving outside the cell. So there will be a decrease in the potential like this 1 point. Okay, after this there some other channel will open known as calcium channel, and calcium will start moving inside the cell. So calcium is moving inside. Now the sodium channel have closed. Calcium is moving inside and potassium is moving outside. So there is a balance. So we will see a plateau phase. Okay, the second one. So there will be a plateau phase. After this, the plateau phase, there the calcium channel will be closed. These are closed. These are closed. Only the potassium channel are open, and potassium will keep on going outside the cell. Okay, now what will happen? The cell will be deprived of positive ions, mean cations, and it will start repolarizing. So membrane potential will goes on like this in 3, and the cell will be repolarized, reach to its resting membrane potential in 4, like this one in the starting. Okay, this is happening inside the myocardium, but at the same time there are some channel present. These are the electrical windows known as gap junctions. So what gap junctions do? They actually provide a way for these positive ions to move inside the next cell. So the electrical activity which was happening inside the first cell, now this will goes on toward the next cell, and like threshold will reach, sodium ion will move inside, then after this they will close, and then potassium will goes out, then calcium, then plateau phase, and whole of the cycle will repeat it. So electrical activity move from this cell, first cell, to the second cell, and then it keep on. So that's how the electrical activity spreads along the whole of the heart. Okay, after discussing the electrical activity, let us discuss how we are able to understand or detect the electrical activity happening inside the myocardium. Okay, so this is a device known as galvanometer. So what does galvanometer? It is basically a device that is used to detect the electrical activity. So we connect normally it with the wire. If the wire is dead, mean there is no electrical current present inside the wire. So galvanometer will not show any kind of reflection, like the needle is present on 0. This means that there is no electrical activity, but if there's any kind of electrical activity present, this needle will show deflection like here or here. So if there's any electrical activity, the galvanometer will show us deflection. So let us consider in the first week, let us consider this tissue of myocardium. It has cell present inside it, and we connect it with a galvanometer. As we know, galvanometer has two, positive and negative, and we connected this part with positive and this with negative. So all of the cell present here are at resting membrane potential. This means that there is no electrical activity, so there is no moving current. All the cells are present at the same phase. Okay, so galvanometer will not show any kind of deflection in the first case. In the second case, there is depolarization. As depolarization starts, as we know earlier, as depolarization starts, sodium channel will open and positive ion will start moving inside the cell. So that positive ions will start moving, and it keeps on by electrical channels. As we have discussed earlier, the gap junctions, the electrical activity will starts moving. Okay, it will starts moving like this and goes on. So if we are not interested what's happening inside each and every cell, we are interested as a whole. So in our earlier classes we have studied, we make a vector known as combined vector. So it is basically the sum of all of the vectors. So if we make a combined vector, it will be like this. So this is a combined vector like this one. So the positive ion are moving towards the positive road of galvanometer, away from the negative. So remember one thing, if the positive is moving towards the positive, then there will be a positive deflection. So galvanometer will show us a positive deflection. As we know, there are positive and negative in the galvanometer. Okay, so there will be like deflection like this one or this one, anything like that. So there will be a positive deflection in the second case when there is depolarizing. Okay, in third case the whole of the tissue is depolarized. So when the whole of the tissue is depolarized, its condition is like in resting membrane potential. But the things are opposite, because in resting membrane potential there are more negative ion inside, but when whole of the tissue is depolarized, there are more positive ions inside. But all of the ions, all of the cells are in same phase, there is no movement of current, there is no movement of charges. So in that case galvanometer will not show any kind of reflection, its needle will be like on zero again. So after depolarization, as we have discussed earlier, in the end there will be the opening of the potassium channels. So when potassium channels open, there will be first plateau phase and there will be start of repolarization. So repolarization starts from those cells which were the last to be depolarized. So the cells which were last to be depolarized are the first to be repolarized. Okay, these cells like in the last, so they will start of repolarization. And now the vector will be away, because in second the vector will be like this, now vector will be like this, because there is repolarization and electrical current is moving in opposite direction. So it is moving, positive ion is moving away from the positive, so deflection will be negative. So now instead going towards positive 30 positive, it deflection will be like this one in the negative direction. Now consider another condition. So in this case, let us consider we have two tissues. Okay, first one is thin and the other one is a thick tissue. Okay, thickness mean like in the heart the atria is thin as compared to the ventricle. So let us consider this is a ventricle tissue, and the tissue is thick. So this means they have more cells. More cells mean more sodium channels. So more sodium channel mean it will make more currents. So there will be more vector, and the overall resultant vector will be much more greater as compared to the atria. So if we, how we will be able to detect that the vector is greater or bigger as compared to the, so the main thing that differentiate is on the galvanometer. If like in the case of atria, let's consider galvanometer was showing positive 20 when there was depolarization, but in this case the galvanometer will show us like positive 40, because the vector is more bigger, more prominent as compared to the atria. So when thickness increase, the galvanometer will show us a reading which is bigger. Okay, let's consider another case. Consider first and second. The first one is not a good conductor of electric current, and the second one we have specialized tissue like these blue ones. So these are specialized Purkinje cells. So they are good in conduction. They are elongated, so they will show small amount of resistance, and they have more gap junctions. So the ions will move along them in more easy manner. Okay. In the first case, when there is depolarization, the galvanometer will show us a reading. Okay, as we have discussed earlier, but the galvanometer deflection will not be very fast, because the conduction is very slow. At the same, the galvanometer deflection will be also slow. But in the second case, as we have discussed, there are more gap junctions, so current will move more easily. In that case, although the reading, if the reading is same, let's consider we have same thickness both of the tissue, but in that case the deflection will be fast as compared to the first one. Okay.